Hello, students. Today I'm going to be going over section 5.5, modeling with linear equations. I find in general that it's easier for me to teach this section to you if I sort of do this section outside of the book rather than using the examples that are in the book to begin with anyway. What is linear modeling? Well, linear modeling is when we're taking real life situations and we're expressing them in the form of a linear equation. You're probably doing this many, many different times and not kind of realizing that's what you're doing. So let's go ahead and we'll get started talking about the different forms of linear equations that you can use, and we'll start talking about some of the applications that you can use for that, and we'll see whether or not if you recognize some of these problems that you've come across in your life probably already. All right, so there's three different types of form that these linear equations take, and up to this point you have learned several different types of equations anyway, so let's kind of go over those. You've learned about slope-intercept form. Well, what is slope-intercept form? Well, I'm hoping that you have remembered. This is the equation that you need to remember the rest of your life. Why is this not working? Oh, here we go. Y equals mx plus b. What's m? Well, that's the slope. Slope is rate of change. That represents the change in the overall line, whether it's going to be going up, rising, or falling, or not changing at all, staying horizontal. And B is your y-intercept. And that frequently, I'm jumping ahead of myself. I'll get to that in a second. Okay. All right. Now, point slope. What is that? Do you remember that? That's if you're given a point that's on a line and the slope. And that formula is what? Y minus y sub 1 equals m times x minus x sub 1. The point coordinates go where the subscripts are. And of course, slope is in here. And these variables stay put as the variables in the equation, which you're going to eventually rewrite in slope-intercept form. And then the last form is standard form, which is ax plus by equals c. And a, b, and c are integers, and x and y are the variables of your linear equation. Well, there's three different scenarios that you're primarily going to be writing linear equations for, and that's what we're going to go over right now. And each of these different forms lends itself well to that particular to those applications. Okay, so let me just clean this up just a wee bit. All right, so let's talk about slope-intercept form first. Okay, that's the first one. Number one. All right, and we just went over that equation. That's y equals mx plus b. The slope-intercept form of a linear equation works best if you're given a rate, which of course that rate is going to be your slope. That's going to be m, and a starting point, some starting point that that the whole thing starts from, and that's going to represent your y-intercept. So your rate is always going to be m, or slope, and b is going to be your starting point. And then you're going to write it in y equals mx plus b form. So you're going to be taking English and translating it into math. You're going to figure out what the rate is. You're going to figure out if there's a starting point. You're going to get those amounts, and you're going to translate that into the slope-intercept form of a linear equation. All right, so that's scenario number one. Scenario number two, when you're doing linear modeling, is the information will be, you're still going to be given a rate of some kind. Something is happening per something. And so that anytime you see some sort of rate, something per something, that's a rate. That's always going to be slope. But if they give you several points of data, they say this has been happening over a 10-year period, but in year 7, this happened. Well, that's the equivalent of them giving you a point out of several points of data. So if you're given a slope and you know a point, what form are you going to use? You're going to use point slope, of course. So your rate, of course, is going to go right here. The point in time is going to go right here. It's going to be in an XY as an ordered pair. So one of the axes will probably represent something like time, and the vertical axis will represent, whatever that's representing, and you're going to put the X and the Y in there of the point in time that they're giving you. And if this seems kind of, murky right now, just wait until we start going over some of the examples. And then the third scenario is you're given kind of a mixture of things going on, of two things at this point because you're in Algebra 1, but you have so much of this one type of thing and so much of this other type of thing, and it's all going to equal to something else. Well, that's when you're going to be using the standard form of an equation, and your mixture, you'll have one item being this and the other one being this, and some relationship set up between all that. All right, so bottom line, you got three different forms of linear equation. Slope-intercept form, which lends itself to a rate and a starting point. Point-slope form, which lends itself to a rate and some data point that they've offered you out of a whole bunch of data. Then you're going to use point slope, and then if you have a mixture, it's going to be standard form. All right, so now let's take the back of the sheet now, and bring that in, and just talk about a few of these, and then I'd like you to work on these yourself. All right, okay, let's see, how do I get rid of this? Okay, I know. All right, here we go. Sorry, just getting the gist here. All right, so on the back of the sheet, you're going to see these word problems that we're going to do. And we're going to do a few of them together, but then I'd like you to take a cut at it and then do them yourself. And then we'll go over them. All right, so number one. Number one situation. Okay, let's read this. It says you want to rent a rowboat for a fishing trip. It costs $8 plus $12 per day. Write a linear model reflecting this situation. Now, the thing you're going to have to realize is that, this is all in English and you're going to be translating it into math. And so they're not going to necessarily give you all the information in order. They're not going to say, here's the slope, here's the starting point. That's going to be up to you to interpret that by reading that. Okay, so we want to represent the amount that it's going to cost us to rent a rowboat, given what they're giving us. Okay, so now let's take a look at this. The two numbers that they're giving us is they're saying it costs $8 plus $12 per day. Well, so what is the $12 per day representing? Is that a starting point or is that a rate? Well, that's a rate, right? Because you see that word per, $12 per day. So that's telling you that this is a rate. And what does this $8 mean? The $8 is that's kind of like a starting point. No matter how long you have the boat, you're going to pay $8 out no matter what. So $8 is going out even on day 0. It's going to cost $8. Okay. On the first day, how much is it going to cost? Well, it's going to cost $12 for the day plus the $8. On a second day, well, that's going to be 24. You see what's happening here? This is a multiplier. That's why it's slope. And then, that's going to be 24 plus the 8, right? So that becomes 32 and so forth. So this $12 per day is your slope. And this $8 is your starting point. So that's your y-intercept. So could you write the linear equation to represent this this scenario? Well, yeah. Well, it's going to be y equals mx plus b, right? It's going to be y equals, well, what's m? 12. So this is 12x plus your starting point 8. So this equation will give you the cost of that rowboat for any given day. Okay, so I'm hoping that makes sense. All right, so number 2 says you would like to record a song in a music studio. It costs an initial fee of $50. Okay, that's almost like initial fee, another way of saying starting point, plus $75 per hour. All right, so what is 75 representing? Well, that's again another rate. So that's M. This is a starting point, so that's B. So can you write the linear equation for that in slope-intercept form? Yes, you can. Y equals 75x plus 50. All right, now let's look at number 3. Number 3, you're buying jeans and shirts at a sale with $120. Jeans cost $40, shirts cost $20. Write a linear model reflecting this situation. All right, this looks like a mixture. I'm buying jeans and I'm buying shirts. I'm buying a mixture of things, and they cost certain amounts, and it's going to total up to this. So we're going to use the standard form of a linear equation. AX plus BY equals C. Well, why don't we let jeans be X and we'll let shirts be Y? Well, how much do jeans cost? Well, they cost $40. So that's 40X plus, and shirts are going to be Y, and shirts cost $20. So that's going to be 20Y equals the total amount of money I have to spend on it, which is 120. So there's my linear equation. So no matter which configuration I set up, it's got to equal 120. Okay, and so standard form is the best way to represent this type of scenario. All right, now let's take a look at number 4. It says you have $9 to buy fruit for a fresh fruit tray. Grapes cost $3 and plums cost $1.50 per pound. Write a linear model reflecting this situation. All right, so what do we have here? Do we have a starting point and a rate? Do we have a point out of a bunch of other points and a rate? Or do we have a mixture again? Well, if you said mixture, you would be right. So we're going to be using the standard form again. All right, so what I'd like you to do now is I'd like you to pause this video and see if you can write this equation out yourself. And this one violates the rules a little bit in that, we're using money here, and these are not integers, but it's okay to go ahead and write it like that anyway. So pause this now, see if you can write this equation out, and then press play. And I'm going to continue, so you pause it now. All right, if you're coming back, I'm hoping you have already written out the equation here for 4. But this is, again, one of these mixture situations. And why don't we call grapes X and we'll call plums Y. So you've got 3X plus 1.5Y is going to equal the total amount of money you have to spend, which is $9. So there's your equation that you're going to have there. All right, now, in number 5, it says in 1995 you had an investment worth $1,000. For the next 5 years, it decreased in value by $50 per year. Write a linear model for the value of your investment. And here they're saying instead of using X, you're going to say you're going to let T equals 0 represent 1995. Okay, so our time is going to be like our X variable, and our investment will be Y. All right, predict the value of the investment in 1998. Okay, so what do you have here? What does this $1,000 represent? Well, that represents a starting point. And then this $50 per year represents a rate. But this is the other important word here. It decreases. So if this 50 is slope and we want to decrease here, what does that mean for the sign that's going to be on that $50? Well, it's going to be negative. So our slope is going to be a negative 50. Our starting point is going to be 1,000, and you're going to write this as y equals negative 50. Instead of x, we're using t. Negative 50t plus, sorry, this t and plus looks the same here. I'm going to make it a little more script-like. Plus 1,000. There you go. So there is the equation for 5. All right, let's look at 6. You already have $200 in your bank account. Your parents give you an allowance of $25 per week, which you deposit directly into your bank account. You don't spend any money over the next year. Write a linear model of the balance in your bank account at any point during the year. Well, what's the situation we have here? You have $200 and then you have a rate of 25 per week. So how are you going to write this? Well, again, it's going to be slope-intercept. So why don't you press pause and write this out and then press play and check it. All right, coming back. I'm assuming you have done 6 on your own here. You should have come up with y equals 25x plus 200. Okay, 200 you have already to start with. You're just going to keep adding to it. All right, let's look at 7. You're buying carrots and peas for dinner. The carrots cost $1.50 per pound and the peas cost 75 cents. You have $4.50 to spend. Write a linear model reflecting this situation. All right, I want you to press pause and see if you can do this on your own. All right, if you're coming back, I'm hoping that you have written out 7. This is another one of those mixture situations. So you're going to be using the standard form again, ax plus by equals c. And of course, we're talking about money here, and they're not too picky about the whole integer thing here. So you can just write it out the way you see it. So why don't we call peas x, and we'll call what's the other? Oh no, so carrots. We'll call carrots x, and we'll call peas y. All right, so carrots are $1.50, so 1.5x plus 0.75y, and what's the total amount you have to spend? $4.50. $4.50. And technically speaking, I guess I could write this in standard form. With integers, I would have to multiply everything by 100, to move the decimal place. But this is sufficient right now for what we're doing, and so we're not being too picky about the whole integer thing as far as the money situation goes. But anyway, this linear equation represents this situation, and so you could pick different x's and y's here as long as it equals 450. That's what you can get. And of course, the single graph into a line. All right, now let me clean this up just a wee bit. All right, so let's read number 8 together. Problem number 8 says you're riding your bicycle from Orlando, Florida to Burlington, Vermont. And it's approximately 1,363 miles. You cover 100 miles per day. On day 8, you are in Charlottesville and you have covered 800 miles. Write a linear model reflecting how much distance you'll travel over the days of the trip. All right, so this scenario is one where you are given a rate and you're given a snapshot in time, a point in time. Like on day 8, you have covered 800 miles. So in other words, your rate is m, which is 100 miles per day, and you have a point. Day 800 miles. Okay, so the x variable represents the time. The y variable represents the amount of distance you've covered so far. So what method are you going to use here? Well, if you said point slope, you would be correct. So you're going to write this out in point slope, and of course you're going to massage it and ultimately get it in slope-intercept form. But to start with, you're going to write this as y minus 800 equals slope, which is 100, x minus 8. And do the algebra, to rewrite this in slope-intercept form. And I think it all kind of works out kind of nicely anyway. You could have done this probably in an intercept form to begin with, just because that you're doing 100 miles per day, and it all works out. So this becomes 100x minus 800, and you're going to add 800 both sides, and you get this. You ultimately get y equals 100x. All right, and now the last one, number 9. You receive an inheritance. You're you are spending, here, let me move this, clean this up a little bit. You are spending your inheritance at a rate of $125,000 per year. 5 years after receiving your inheritance, you have $1,200,000 left. Write a linear model reflecting how much money you will have after several years. All right, so this is number 9 is a lot like number 8 in that you have a rate of spending $125,000 per year. Okay, and you are told that 5 years after receiving, you have this much left. So you're given a rate, and again, you're given a snapshot in time. Your rate is going to be, now remember, we're spending money, right? So is the sign on this going to be positive or negative? Relative to the amount of money that you're going to have left. Well, it's going to be negative. You're going to be subtracting this amount. So your slope is 125,000, is negative 125,000. The point in time is 5 years. So 5 years into it, that's your x coordinate here. You have 1,200,000 left. All right, so again, you're going to do this in point slope form. So why don't you pause the video and see if you can write this out yourself and come up with it. And then come back. All right, so if you are coming back, we're going to be putting this in point slope form. You're going to have y minus y sub 1. Well, that's this value, right? 1,200,000 equals your slope, which is going to be a negative 125,000. I'm going to run, there we go. Minus 125,000, x minus, and what did we say? That was 5 years, right? Minus 5 years. All right, so there it is. And now you just got to crunch the numbers and, write it in slope-intercept form. So 1,200,000, that's going to equal negative 125,000. X plus, what is 125 times 5? I think 125,000 times 5. So that's going to be minus, that's plus $625,000. And then what we are going to do is we're going to then add this on there. Oh, yeah, you're going to see what you originally had. So that's the starting, that's what we're going to do. Okay, so now we're going to add, we're going to add 1,200,000 to both sides. All right, and now you're going to get y equals, that goes out, negative 125,000 x plus 1,825,000. There you go. And that was your inheritance to begin with, and you've already spent 625,000. You are squandering your inheritance based on this linear model. That's what it says. All right. I hope that helps. And with this little video, if you are having trouble with section 5.5, you'll be able to handle the homework for it now. If not, let me know, and I can give you some help. All right. Thanks.